It wasn't just a new weapon. It was a fundamental rewriting of the laws of thermodynamics. It was a substance designed to perform a task that nature never intended, to make water burn and to make fire heavy. How did a team of academics, hidden away in the polite, ivy-covered silence of a university campus, manage to synthesize a hell that would eventually consume more human lives than the atomic bomb? Why did the world's most advanced military machine find itself paralyzed by something as simple as a sloping roof? And why was the solution to a global war hiding not in a steel foundry, but in a mixture that looked, smelled, and moved like raspberry jam? But the history books focus on the B-29s that dropped the canisters. They ignore the desperate chemistry of the men and women who filled them. The turning point of the war in the Pacific wasn't decided by a general in the Pentagon. It was decided by a frustrated scientist fighting a war against gravity itself. He was ignored because his weapon wasn't made of high explosives, but of soap. Why did the system nearly reject the only invention that could guarantee their victory? The answer wasn't in the strategy manuals. It was in the stained hands of the invisible laborers mixing the jelly in a converted squash court. July 4th, 1942, Cambridge, Massachusetts. While the rest of the United States is celebrating Independence Day with parades and fireworks, the mood inside the Converse Chemical Laboratory at Harvard University is suffocating. The air here does not smell of barbecue or summer rain. It smells of benzene, fatty acids, and the acrid sweat of failure. Dr. Louis Fieser stands over a lab bench, staring at a beaker of gasoline. He is not a soldier. He is an academic, a man of theory and formulas. But the war has breached the walls of the Ivy League. The conflict raging across Europe and the Pacific has turned this sanctuary of learning into a frantic workshop of destruction. And right now, Dr. Fieser is losing. The problem facing the Allied forces is terrifyingly simple, yet technically impossible. The United States has the planes, they have the pilots, they have the bombs, but they cannot set the enemy on fire. The target is Japan, a nation of wood and paper. In theory, their cities should be tinderboxes, waiting for a single spark to turn them into ash. But the system, the massive bureaucratic machine of the War Department, has overlooked a basic principle of physics. They are dropping standard liquid gasoline. But gasoline is a volatile, impatient creature. When a canister of liquid gas strikes the roof of a Japanese house, the physics of the impact betray the attacker. The canister shatters. The fuel inside, moving at terminal velocity, behaves exactly like water. It splashes. It creates a magnificent, terrifying flash of orange light, a Hollywood explosion. But it is a lie. Because the fuel is a liquid, it obeys gravity. It runs off the tiles. It flows down the gutters. It drips harmlessly onto the street below. It burns up its energy in seconds, creating a burst of heat that is too fast to ignite the dense wooden beams of the structure. It washes the roof rather than destroying it. The reports coming back to Fieser's lab are humiliating. The pilots are risking their lives to drop tons of incendiaries, only to have the fires wink out before the planes even turn for home. The system, in its infinite arrogance, demands a bigger fire. The generals in Washington are screaming for more tonnage, more heat, more planes. They believe that if you throw enough money and explosives at a problem, the problem will cease to exist. They are wrong. Dr. Fieser knows that brute force is useless here. He doesn't need a hotter flame. He needs a crueler one. He needs a fire that acts like a parasite. The goal is to create a substance that rejects gravity, a fuel that hits a surface and stays there, a fire that clings to wood, to metal, and to skin. But the chemistry is fighting him. To thicken gasoline, the standard practice is to use raw rubber. It works perfectly. It turns the fuel into a sticky, devastating paste. But then the boss walks in. This time, the boss isn't a general. It is geopolitics. Japan has conquered the rubber plantations of Malaya and the Dutch East Indies. 90% of the world's natural rubber supply is now in enemy hands. The United States is starving for rubber just to keep its trucks and jeeps moving. There is none left for bombs. The War Department delivers the news to Fieser with the cold finality of a death sentence. Find a substitute, or the bombing campaign stops. This is the friction point. The system demands a miracle weapon, but denies the scientists the only ingredients known to make it work. The lab becomes a pressure cooker. Fieser and his team are now racing against two clocks: the progress of the enemy abroad and the patience of the bureaucracy at home. They begin to test everything. They raid the chemical pantries of the university. They mix gasoline with resins, with soaps, with glues. They are looking for a specific viscosity, a texture that occupies the uncanny valley between a solid and a liquid. If the mixture is too thin, it runs off the target. If it is too thick, the explosive burster charge inside the bomb will just splatter chunks of cold jelly that fail to ignite. It has to be perfect. It has to be fluid enough to spread, but solid enough to stick. The team works through the nights. The glamour of scientific discovery is stripped away, replaced by the mundane horror of trial and error. They are mixing death in buckets. And here lies the first great irony of this story. The generals see the war as a map of arrows and territories. They believe victory comes from the size of the army. But in the sweltering heat of the Converse lab, Fieser realizes that the fate of the war hinges on something far more domestic. They are essentially trying to make a very specific type of mayonnaise. The black box of this weapon is not a fuse or a detonator. It is a chemical bond. They need to create a matrix, a sponge made of molecules that can soak up gasoline and hold it hostage until the moment of impact. And they are failing. Every test ends in a puddle or a dud. The generals are growing restless. There is talk of canceling the project, of reverting to high explosives that shatter buildings but leave the rubble intact. The system prefers the weapon it knows, even if it doesn't work, over the experimental weapon that might. Fieser feels the weight of the ivory tower collapsing. He is not just a chemist anymore. He is a man realizing that his intellect is the only thing standing between the war effort and a total strategic stalemate. He looks at the periodic table not as a chart of elements, but as a list of suspects. Somewhere in the columns of carbon and hydrogen, there is a combination that will unlock the gates of hell. He just hasn't found the key yet, but he isn't looking alone. While the great men of history argue in boardrooms, the real work is being done in the shadows of the lab, by the hands that history usually crops out of the photograph. The solution is coming, and it will be born from the most innocent of materials. Naphthenic acid, palmitic acid, two common substances found in soap. The moment is approaching, the moment when the sticky fire is born. But the creation of the weapon is only half the tragedy. The true horror begins when they realize that to test it, they can't just burn wood. They need to know if it burns flesh. Late 1942. The war has moved indoors. We are no longer in the high-tech laboratories of the main campus. The project has been exiled to a space that defines the absurdity of this moment. A converted squash court. Where wealthy students once played leisure sports, a team of young technicians and female assistants now stand over galvanized buckets. They are the invisible gears of the war machine. History records the names of the generals and the lead scientists, but it forgets the hands that actually held the ladle. These assistants are not soldiers, they are civilians. They wear lab coats, not fatigues, and they are about to perform a culinary act that will change the temperature of the world. The recipe is simple, almost insultingly so. They take the gasoline, the volatile, splashing failure that the military hates, and they introduce it to a new partner, a powder. It is a brown, granular dust. It looks like crushed soap. It is a combination of the two acids Fieser identified: naphthenic acid, palmitic acid. They didn't have time for a poetic code name. They simply smashed the syllables together. Napalm. The process begins, and for a moment, it looks like a mistake. As the assistants stir the powder into the gasoline, the liquid doesn't explode. It doesn't hiss. It simply thickens. The amber liquid begins to clot. It turns into a translucent, sticky substance. It takes on the texture of applesauce. Then, as it sets, it darkens into a wobbling, rubbery mass that looks disturbingly like raspberry jam. The black box of death has been unlocked. The mechanics of this jelly are a nightmare of efficiency. When a standard bomb explodes, the blast wave moves outward, pushing the air away. But napalm is different. The gel acts as a sponge for the fire. It slows the combustion down. Instead of a flash that lasts a second, napalm burns for minutes. It clings to whatever it touches. If you shake your hand to throw it off, it does not detach. It strings out. It transforms the victim into the fuel source. But the system, the rigid military hierarchy, observing from the sidelines, is unimpressed. A colonel from the Chemical Warfare Service arrives to inspect the progress. He looks at the buckets of sludge. He sees a substance that looks like spoiled food, not a weapon of mass destruction. He embodies the crystallized arrogance of the era. He scoffs, looking at the mess on the floor. You want us to load this into a bomber? It's glue. The Germans have rockets, and you are offering us sticky paste. He sees the lack of sophistication as a weakness. He believes that lethality must look industrial, metallic, and precise. He cannot conceive that a bucket of slime could be more dangerous than 1,000 pounds of TNT. He is about to receive a correction from physics. The team moves to the testing ground. It is a crude setup, a wooden structure built to mimic the fragile architecture of a Japanese home. They load the gel into a modified canister. The fuse is lit. The explosion is not a sharp crack, but a dull, wet thump. The colonel watches, ready to write the report that shuts the project down. He expects the fire to splash and die, just like the gasoline. But the fire doesn't run, it jumps. The jelly sprays across the wooden walls. It hits the eaves, and then it stays there. The flames begin to crawl. They don't just burn the surface. They cook the wood from the outside in. The temperature spikes to over 1,500 degrees Fahrenheit in seconds. The technicians rush in with water hoses, playing the role of the enemy fire brigade. This is the moment the colonel expects the weapon to fail. Water is the universal cure for fire. But when the water hits the napalm, the fire hisses, spits, and burns brighter. The gel is hydrophobic. It repels the water. The stream from the hose simply spreads the jelly further, carrying the burning infection into the cracks of the floorboards. The fire uses the water as a highway. The colonel stops writing. The mockery drains from his face, replaced by a cold, dawn-breaking horror. He realizes he isn't looking at a bomb anymore. He is looking at a plague. Back in the squash court, the mood is electric. The assistants and the chemists are cheering. They are high-fiving. They have solved the riddle. They have cracked the code of the sticky fire. And here is the bitter aftertaste. In their joy, they see only the chemistry. They see the successful polymerization of a colloid. They see a problem solved. They do not see the future. Because they are in Cambridge, Massachusetts, the fire is an abstraction. It is a scientific triumph. They cannot smell the burning flesh of the civilians who will wake up to this jelly raining through their roofs. They cannot hear the screams of a city where the rivers themselves are on fire. The distance between the maker and the victim is the true blind spot of the 20th century. Dr. Fieser writes in his notes about the excellent stability of the GL. He describes it with the pride of a father. He has given the system exactly what it asked for. He has created a sun that never sets. The weapon is ready. The chemicals are stable. The system, once skeptical, is now hungry. They order tons of the powder. They order the conversion of factories. The raspberry jam is going to mass production. But as the crates of napalm begin to pile up on the docks, waiting for the long journey to the Pacific, a final, dark irony begins to take shape. The weapon was designed to destroy military targets, to burn factories and shipyards. But the wind over Tokyo is unpredictable, and the B-29 bombers fly very high. When you drop a fire that cannot be put out, you stop being a soldier targeting an army. You become a force of nature targeting a civilization. The scientists have finished their work. Now, the pilots must start theirs, and the world is about to learn that there are some fires that water cannot cleanse. Only time, and time is running out. March 9th, 1945. The dark skies over Tokyo. The wind is blowing at 20 knots. In the cockpit of the lead B-29, the pilots feel the turbulence. They are flying low, stripping away the safety of altitude to ensure the delivery is precise. They are not carrying high explosives. The bomb bays are stacked with clusters of the M69, thin hexagonal pipes, filled with the raspberry jam from the squash court. The system has given the order, Operation Meeting House. The doors open, and the cylinders fall. At 2,000 feet, a small charge bursts the clusters open. The individual bombs don't scream as they fall. They flutter. They are stabilized by long cloth streamers, descending like a rain of dark confetti. To a civilian on the ground, looking up, it might have looked almost graceful. Then, they strike the roofs. The black box of the disaster activates. The mechanism is no longer chemistry. It is thermodynamics. When thousands of these canisters ignite simultaneously, they do not create separate fires. They create a chimney effect. The heat is so intense that the air above the city becomes lighter than the air around it. It shoots upward into the stratosphere. This creates a vacuum at ground level. Fresh, oxygen-rich air from the surrounding countryside rushes in to fill the void. This isn't a breeze. It is a hurricane generated by heat. The fire begins to breathe. It sucks the oxygen out of the lungs of the people running in the streets. The wind screams at 50 miles per hour, but it isn't blowing the fire out. It is feeding it. The city of wood and paper does not stand a chance. The temperature hits 1,800 degrees. Glass melts, iron warps. The canals, the designated safety zones, where families were told to run, begin to boil. And here is the cruelest irony of the night. The people did exactly what instinct told them to do. They ran to the water. They jumped into the Sumida River to escape the heat. But Fieser's invention was waiting for them. Because the jelly floats, the river caught fire. The napalm bled from the warehouses and the shattered homes, running down the streets and pooling on the surface of the water. The fire followed the fuel. The sanctuary became a cauldron. In the morning, the silence was louder than the bombs. 16 square miles of the world's most populous city had vanished. It wasn't rubble. It was ash. Over 100,000 people were gone, more than would die in the instant flash of Hiroshima or Nagasaki. The system called it a strategic success. The generals praised the efficiency of the burn rate. The report on Dr. Fieser's desk confirmed that the viscosity was perfect. The gel had stuck. But the victory came with a stain that no amount of metals could cover. Louis Fieser returned to Harvard. He continued his career. He was a brilliant man, a celebrated chemist who would go on to synthesize cortisone, a drug that relieved the pain of millions. But history is a ruthless editor. It does not remember him for the healing. It remembers him for the burning. Fieser spent the rest of his life defending his creation. He argued that he was just a scientist, that he had no control over how the military used his invention. He claimed he built a tool to end a war, not a weapon to end humanity. "I have no guilt," he once said. "You don't blame the guy who sells you the rifle for the murder. But this is the final, bitter aftertaste. The rifle does not burn a city because it is raining. The rifle does not turn a river into a grave." The tragedy of the sticky fire is not just in the death count. It is in the disconnect. It is the story of how decent, intelligent people can sit in a quiet room, solve a technical puzzle, and never feel the heat of the hell they are building. The technicians in the squash court weren't monsters. They were patriots. They were doing their job. And that is what makes it terrifying. Today, the squash courts are gone. But the labs are still there. We are still mixing new compounds, writing new algorithms, and building new drones. We are still solving problems in quiet rooms, separated from the consequences by screens and oceans. We tell ourselves that our systems are precise, that our smart weapons are humane. But when we look back at the ashes of 1945, we have to ask ourselves, are we safer because we have perfected the science of destruction? Or have we just become better at washing the jelly off our hands? The fire eventually went out, but the question still burns. If you believe that the stories of the scientists who built our world deserve to be weighed, both the brilliance and the burden, please join our ranks by subscribing. We have synthesized this narrative from reputable historical archives and verified sources. However, the fog of war often extends to the history books. If you spot any inaccuracies or have additional details to share, please correct us in the comments. We strive for the absolute truth, and your knowledge helps us get there. Thank you for keeping history alive.